Now we turn to quadratic equations. A quadratic function of one variable x is a function that can be written in the form, this is like your y, okay, so f of x stands for y, it's a y value, it's equal to ax squared plus bx plus c. And here we don't let a be equal to 0, otherwise if this is 0, then what you have is just a linear function. So the function f of x equal to ax squared plus bx plus c is also called a second degree function because the highest power that occurs in the x is 2. So the domain of a quadratic function is the set of all real numbers. And it says why? Well, because I can plug in any x here and you can square any number, whether it's rational or irrational, you know, any number. And then again, it can be multiplied by a constant or a real number. And then this part is just a real part. We know that the linear part. So we know that a linear function is the domain is all real numbers because you can plug in any number for x basically. There's no restriction. Alright, so now let's keep going. How does the graph of a function that's of the form, okay, so what's the form? We've got f of x is equal to ax squared plus bx plus c. Now if b is 0 and c is 0 and a is 1, you've got the simplest function for a quadratic would be x squared. Okay, another function that it may look like, so these are just examples. So you've got you can have a coefficient that's negative, say minus 2x squared plus 3x. That's another one, which means here the constant c is 0. Another example would be, say, f of x is equal to 3x squared plus 4x minus 5. That's another quadratic because as long as the highest degree that occurs is 2, right there. So here's where a is 3, b is 4, and c is negative 5. Now it says here that the graph of any quadratic function is u-shaped or an inverted u. Now that will depend on whatever's the coefficient of x squared. Okay, so how do we graph the quadratic function f of x is equal to x squared? What we can do is just generate a few ordered pairs. Let's try doing that. So let's say this is x, and remember our y is f of x. So what I'm going to do is just plug in a few numbers. Let's say negative 2, negative 1, 0, 1, and 2. So all you do is just square negative 2, and when you square negative 2, okay, so f of negative 2 is just, remember, when you say f of the argument is whatever you plug in for the x, so negative 2 squared, so that's 4, so that's 4 right there. F of negative 1 would be negative 1 whole thing squared, so that's 1. 0 squared, f of 0 is 0 because 0 squared is 0. And then f of 1, as we know that 1 squared is always 1. And of course f of 2, when you square 2 you get 4. So if we plot these, what are we going to get? What we have is, okay, so from minus 2, minus 1, 0, 1, 2, 1, 2, 3, 4. So let's plot the first ordered pair, negative 2, 4. Which quadrant are we looking at? Where does it belong? Well, the x is negative and the y is positive. So remember, these are your y and x axis. So we got right there because this is 4. And then we have negative 1, 1. And then 0, 0. 1, 1, and 2, 4. So if we look at how this behaves, it looks like a U-shaped, and it's symmetric about the y-axis if you have this form. Okay, so what is the domain? The domain is all real numbers. And then based on the graph, what do you think is the range? Well, if you notice that the least value for y is 0 and the rest are all positive, because whether it's negative or positive, when you square it, you always get a positive number other than 0. So our range would be, and again, if you use the graph, you can put a bottom for the box, but you cannot put a lid because this y values will keep going up to plus infinity. So you start from 0 for the y, and as the graph goes to positively unlimited, then that's why the range is from 0 to infinity. Alright, so the question now is, suppose we have these types of functions where there's an additional terms there. Okay, there are additional terms. How does the graph look like then? Okay, it turns out we have a formula. So a quadratic function f of x that looks like, you know, say f of x could be equal to, that could be like the example in the previous slide. You have 2x squared plus 3x minus 7. Okay, see, that's what this means. A is 2, okay, B is 3, and C is negative 7. It turns out that if you have this kind of form of the function, you can always rewrite it in this way. Okay, this way. So what this is that it's a translation of the vertex, that the vertex is the minimum point of the parabola or the maximum point, depending on whether your parabola is facing up or facing down. Okay, so if it's facing down, that's your vertex right there. If it's facing up, then this is the vertex. It's the minimum value or the maximum value. Now what would determine whether it is a U-shaped or an inverted U-shape? It depends on what A is. So if A is negative, then it goes this way, and if A is positive, then you have a U-shape. Okay, so how does that work? How do we find it? How do we find these values? It turns out that there's a formula. Okay, so the formula here is minus b over 2a. Remember what minus b over 2a is also occurring. Remember, this also occurs in your quadratic formula. And then what this k means, that means the k is the y coordinate every time when you plug in h. So that's why when you say k is f of h, that means k is f of what is h minus b over 2a. So this is what we call the vertex of the graph. So it's either a maximum, okay, so the vertex could either be maximum, it could also be minimum. So it becomes a maximum when the coefficient of, when this a is negative, and it's minimum when a is positive. Alright, so let's see if we can try to graph a function. So here's the shape, and like we said, when a is positive, then you have a vertex occurring there, and if a is negative, then you have a maximum for the vertex. So what is the vertex? The vertex is where, if you draw a line, a vertical line through the vertex, it divides the graph of the parabola symmetrically. Okay, so it's symmetric about the vertical line where it passes through the x-coordinate of the vertex. Okay, so here, this is the h, and that's your k. Here is h, and there's your k. That's why those are the coordinates. Okay, so let's see. Graph the following quadratic functions, locating the vertex and the x-intercepts, if any. So let's turn to letter A. So let's try graphing this function. So if it was written in this form, that means the pattern would be, this is going to look like f of x is equal to x minus h squared plus k. Okay? Go back to the previous slide. See here, it's now of the form h and k. So you see how this is the coordinates of the vertex. So let's go back and see how that looks like. So in order for this to look this way, that means this should be an opposite sign. So another way of writing this is x minus a negative 1 squared plus a minus 4. Do you see that? How it should follow this pattern, which means that the vertex would be negative 1 and negative 4. So if ever you see something like this, take the opposite sign. That's the x-coordinate of the vertex, and then this, just copy whatever it is. So that's your vertex. Now the question is, okay, so this is now your vertex. Okay, so I'll just use V to mean the vertex. Now it says here also locating the x-intercepts. So how do you find the x-intercepts? Well, that means if we set, so to get the x-intercepts, in other words, the question is if this is the vertex, all right? So think about it. You've got a vertex occurring where? Occurring at negative 1 and then a negative 4. Okay? So here it is. But we know that because A here is understood to be 1, you know, then that means it opens upward. So if it opens upward, eventually this graph is going to cross the x-axis. Those are your x-intercepts. And what are those? That's the question. What are the coordinates of these 2 points where it crosses the x-axis? These two is how you can get the x-intercepts. In other words, that means, what is the y-coordinate for these 2 points? The y-coordinate is 0, so that means this whole thing is 0. So to get the x-intercepts, all you need to do is solve this equation. X plus 1 squared minus 4 is equal to 0. So we solve for x, we add 4 to both sides, right? Add 4 to both sides, and we have x plus 1, okay, squared is equal to 4. And then take the square root of both sides, which means we have to take plus or minus square root of both sides. You get x plus 1 is equal to plus or minus 2, because the square root of 4 is 2. And then add negative 1 to both sides. So you've got x is equal to negative 1. I'm just putting the negative in front, okay? Plus or minus 2. So you have 2 x's. So one of them is that x, all right? So x is either negative 1 plus 2 or x is minus 1 minus 2. So if that means these points is where x is equal to negative, this is equal to negative 3, right? And this is equal to 1. So see, that means this is negative 3 and that is 1. So what are the 2 ordered pairs that we can write now for the x-intercept? It'll be when x is 1, y is 0, and when x is negative 3, y is 0. So these are the 2 x-intercepts. Alright? So that's how your graph looks like. Okay, which means that if your vertex opens upward, and it's above the x-axis, then you don't have any x-intercepts. There's no x-intercepts. Okay? So what did I say again? If you have a vertex that is above the x-axis, okay, let's say the vertex is somewhere here, okay, somewhere along here, somewhere, then if it opens upward, then you know it'll never cross the x-axis, so you don't have any x-intercepts. That's why in the homework, if they ask you, are there any x-intercepts? If the result of getting these, solving this is imaginary number, then that means there are no x-intercepts. You have 0 x-intercepts, or they don't exist. Okay, now here is another way of graphing. How do we graph the following? Okay, so it is not of the form hx is equal to a times x minus h squared. Oh, let's not, okay, it's okay. plus k, like the previous slide. You see the previous slide looks like that? See, there's your x minus h plus k. Here, it's just the usual quadratic form. So there's another, if it's not of this form, then you use the formula. Okay, what's the formula? Use the formula that where h is equal to minus b over 2a, and then your k is just plug in x equal to minus b over 2a into the function. Okay, the function, to get the function, in this case h of x, to get the x coordinate, to get the y coordinate of the vertex. Okay, so let's try that. That means we define a here to be -1, b is 6. So that looks like what? Well, that means h is equal to negative of 6 over 2 times -1. So you have negative over negative is positive, 6 over 2 is 3. All right, so so far our vertex has the form 3, and then we don't know what the y coordinate is. Well, all you have to do is plug in 3 into the x here for the quadratic equation, function, so h of 3. So that means, what is h of 3? H of 3 is equal to negative. Now here, this is not -3 whole thing squared. Instead, you have a negative of 3 squared. Okay, so we have to make that clear. This is not -3 whole thing squared. Instead, you square 3 first and then take its negative. So h of 3 is equal to the negative of 3 squared plus 6 times 3 plus 7. You're going to get minus 9, right? And then plus 18, which is actually 9, plus 7, then you get 16. So that means the vertex, is therefore equal to the point where x is 3 and y is 16. Right, so if you have this situation, that means, let's graph that. How does the graph look like? So what I'm going to do is get a clean, erase everything. So far we say that the vertex was 3, 16. So if you graph that, right? So let's just assume that this is 8 and 16, and then say this is 3. Okay? So there's your vertex. But since this has a negative in the front of x squared, then it opens downward. It's going to look like that. What does that mean? Eventually, this is going to cross the x-axis. The question is where? Right? So where is that? That will be determined by setting those are your, that's one x-intercept. There's another x-intercept. Okay? So let's see. How do we do that again? So to get the x-intercept, we said that we're going to we were going to get the x-intercepts, right? We solve what? We solve for x here in this minus x squared plus 6x plus 7 is equal to 0. Okay, now it would be easier to factor this if we multiply everything by negative, don't you think so? Or -1 for that matter. So that means that's just reversing the sign. So you get x squared minus 6x minus 7. 0 times -1 is 0. So then we can factor this. What are the factors of -7 so that they add up to -6? that means you got to have a -7 and a +1 here. And when you set that equal to 0, each 0, that means x is either 7 or x is equal to -1. So that means this notch here, that's where x is -1, and that's when x is 7. So what are the x-intercepts? It has to come in, it has to be expressed in ordered pairs. So you have -1, 0, and 7, 0. So there it is. That's -1, 0, and 7, 0. You see what I said earlier, that if the vertex is above the x-axis and this is positive, then you're going to have a parabola that opens upward. You see, it opens upward. That means it will never have an x-intercept. Okay?